Dear friends, in this video we are going to discuss about renewable energy sources. We have here tidal and geothermal energy sources. How we are going to get electricity from tidal as well as from geothermal. Tidal itself gives the meaning of the sea waves, ups and downs, that is alternating sea levels. And another type is geothermal. Geo means geography, thermal means heat. Under the ground, we go from the available heat, we are going to utilize the available heat from the ground, and we are going to generate the steam. So these are the two types of renewable energy sources that we are going to discuss in detail. So the tidal power plants, generally it is classified into two categories. One is single basin, another one is a double basin. In the single basin we have further classification as one way, two way, and two way with the pump storage. Whereas in the double basin system we have simple double basin and double basin with pumping. These are the major classifications of tidal power plants. See, now look at this diagram. Single basin, one way tidal, that is under the sea, due to alternating sea levels, we are going to utilize that tidal energy, that is sea level, up and down of the sea level, and we are going to insert the sluice gate, and we are going to stop the flow, and we are going to release the flow. Stop and open, stop and open. If you do alternatively in both the direction, the sea water will be flowing in both the directions. It will make the hydro turbine to rotate. This is the basic concept. See, now if you look at this single basin arrangement, see here you see the tidal basin. This is the tidal basin. Here it is high tide. This is a sluice gate where we are going to have the turbine generator. When we open, the water will flow from one side to another side and making the turbine to rotate. The turbine blade is connected to the generator shaft and we will get the power. When we close also, the water will be flowing, sea water will be flowing from one side to another side. That also will make the turbine to rotate. So in both the flows, the turbine will be rotating. This is the another layout of tidal plant. Here we have this turbine. It will rotate in when the sea water flows over the turbine blades. This is a power based, that is powerhouse. And how we are replacing this one. See this diagram, which will give you more information. This is the sea water flowing. Here we have the blades. This is called blade turbine. This is called turbine. We have to rotate this turbine blades. This is our aim. When water flows over this, it will make the turbine blades to rotate. When turbine blades rotate, the shaft will rotate and the generator shaft will rotate, and we will be getting the power transmission. That is, the tide is coming in. Next is see. Here this is the arrangement. In the sea, we are going to have the blades like this. When water flows in this direction, it will rotate the blades, so the shaft will rotate and the generator shaft will also rotate. This sluice gate is shutting. We have closed the gate. If you open, the water will flow. If you close, the water will not be flowing. Now we have opened, the water is going out from this side to that side. So this time also the turbine blades will rotate. So this is the arrangement, how the turbines are fixed under the sea. See, this is a wicket gate. The water flows here. It will make the turbine to rotate. When the turbine shaft rotates, this is a turbine generator shaft. It is connected to the rotor, armature winding, and the generator. We are getting the power supply. See, this is a turbine blade. Water is coming in. It rotates. When the turbine goes out, that is the water goes out also, turbine rotates. Also the tide comes in, and again when it goes out, the turbines are driven by power of the sea in both directions. That is a message you have to get. It is a very clear demonstration I am showing here. See, when the sea water flows from here to here, also turbine blades rotate. From here to here also turbine blade rotates. So this is about the working of tidal energy. Now we are going to see the second type of energy, geothermal energy. Geothermal energy we might have studied in the lower standards. Under the earth, we have lot of heat energy. That heat energy we have to take out so that that heat will be utilized to convert the water into superheated steam. Now look at the diagram. How, see, this is the magma, this solid rock. Here we have the porous rock, and we have the surface, that is outer earth surface. Here we have the well. We have bored the well. These two are the well, and this is a salt impervious rock. This is a fissure. Now, if you look at this, under the earth we are inserting the pipe. Under the earth we have the steam, that is the heat. That heat will be utilized to heat the steam, and the steam will be utilized to drive the generator. After that, again it will be going to the ground. In the next diagram, if you look at this, see, this is a hot solution going there and gets condensed, and it again comes back to the geothermal zone. This is a binary fluid system, as we have been discussing earlier in other cases. Both the liquids will be utilized to operate this geothermal power plant. See, now if you look at this, you will get a very clear idea. Heat extraction from the hot dry stock. See, about 3000 meters, that is from the ground level, 3 kilometers depth. And we are going to have the fracture of 200-meter diameter. There we are going to insert, supply the water. The water will be converted to steam. That steam will be drained out, that is trapped out, and it will be utilized in the surface. This is called the sedimentary volcanic rock. At the depth of 3 kilometers or 3000 meters, we have the narrow fracture. There we have hot liquid, that is hot zone. We are supplying the water, and the water will get converted into steam, and we are bringing out the steam. This is the basic concept of geothermal energy. This is another diagram, just animation. From here, see, here, from here we are taking the, we are supplying the water, and we are taking the hot steam. That hot steam will be utilized for power generation. Hot liquid, and again we are supplying back the cold liquid. We are supplying the water and getting it heated, and we are taking out.